Imagine as a kid, you walk into a classroom and you see robots all over your desks. And if the child is not excited immediately, I'm not sure if you walk into a toy store, I'm guessing they won't be excited either.
People have compared the current model of education, where students come in, get knowledge, walk out with knowledge, to a model that was developed for and designed for and really suited for the industrial age, where the purpose of the educational system was to make sure that people were prepared for factory work. And what is factory work? Factory work means working very much like a machine. That is absolutely not what people's role is today. We have machines to do the machine work. And so educating people to do the machine work is both not interesting to them and largely an unproductive use of time.
The purpose of the Robotics Academy is to develop an educational outreach arm of the Carnegie Mellon Robotics Institute, which develops a lot of sort of large-scale technologies on main campus here in Pittsburgh. So what we do is we take those same technologies and we try and make them in an applicable form for students and teachers to be able to sort of teach those same ideas in their classroom, using different types of sensors and robots to eventually turn into teaching the concept of STEM, which stands for science, technology, engineering, and mathematics.
It would be difficult to predict what the fastest growing innovation will be 5 years from now, but we can, with more confidence, we can predict that it's going to involve computer science, embedded systems, applied mathematics, and engineering design.
You can learn all of the same concepts that robots can teach on paper. You know, if you take a look at a wheel, you can figure out that there's a circumference to that wheel, but you don't ever get to see a physical application of it. Being able to take those concepts that are usually very abstract and then be able to show students that, well, if I tell this wheel to rotate and it goes this specific distance, we can calculate and figure out why it went that distance.
Our materials are designed to be student-driven, but teacher-monitored.
Basically work on a lot of new continuing computer science technologies. So one of the main research topics is around our Robot C software, which is a C-based programming language that you can take the same exact program that you work on 3 or 4 different hardware platforms, the virtual platform, and you can basically let students learn all kinds of different physical hardware and robotics hardware while sticking with the same C-based programming language.
So whenever we started teaching robotics, we saw a problem in that if you use it inside of a classroom, lots of classrooms don't have enough robots for students. So what we try to do with the Robot Virtual World software is emulate exactly what the student does with a real robot, but in a simulated environment. And then that way, if they miss school or the teacher wants to assign homework, or if the classroom doesn't have enough resources, they can do all these things at a much lower price point.
So CS2N is the place where teachers and educators can go and get activities for their students, and a lot of the stuff we put out for free.
All of the technology that we're developing will phone home to CS2N so that teachers can log in and actually see the exact progress of all of their students.
And we have what's called badges or achievements. That's exciting because when they get, I got 5 questions right, they get pretty excited about that.
A lot of the critical thinking and problem solving skills that you develop working on a robot challenge or a problem, you're able to apply those in real life.
Robotics is an easy way to get them excited and to get them into and using those skill sets that they need.